I talk to a lot of students and professional developers that often want to start a side project, but aren't sure what to build. In this video, I'll teach you about 5 software projects that taught me a lot. In fact, they're great because you could build them multiple times and learn new things each time. So whenever I don't know what to build or I want to learn a new programming language or framework, I start with one of these: a text editor, a 2D game, a compiler, a mini operating system, a spreadsheet, or a video game console emulator. Number 1, a text editor. We use text editors every day, but do you know how it really works? Ignoring all of these fancy features that your favorite editor has, how would you implement a text box that supports a movable text cursor and selecting, inserting, and deleting text? No, you can't use the built-in text box component from your favorite GUI network. The biggest challenge is figuring out how to store the text document in memory. My first thought was to use an array, but that has horrible performance if the user inserts text anywhere other than in the end of the document. Luckily, there are some nice data structures to learn to solve this. Another hurdle was learning how a text cursor behaves in popular editors. For example, if I press the up arrow key with the cursor in the middle of the document, where will the cursor move? Same column? Not if that line is shorter. Keep pressing up. The cursor will snap back to the original column once a line is long enough. It turns out that the cursor has a memory for the column and tries to get back to it. It is these details that I never noticed until I tried to implement it. After implementing the basic editor, I challenge you to implement 2 more features: undo, redo, and word wrapping. Implementing undo, redo in an efficient way was mind-blowing to me. I first tried keeping an array of previous states, then tried to memento pattern, before finally settling on the command pattern. Word wrapping forces you to separate the visual aspects of a text line from the memory aspects. Some things to learn are data structures for storing the text, behavior and implementation of the text cursor, design patterns for undo, redo, and abstractions to separate the visual and memory aspects of the text. Number 2, 2D game. Even the most simple games require some unique data structures and design patterns. The idea here is to implement a well-defined game from start to finish without getting bogged down on the other stuff, such as game design and art. Also, it is best if you use a bare-bones 2D graphics library. For example, SDL, SMFML, Pygame. Not a big game engine that'll hide all of the interesting bits for you. First, you'll have to learn to draw the screen. I had no idea how this worked. You are actually clearing the screen, then drawing each portion of the screen in rapid succession, many times a second, to create the effect that objects are moving. Second, you'll learn all about the game loop. A game is effectively looping between drawing, getting user input, and processing the game logic. Third, you'll need to know how to process the user input. I never paid attention to the subtleties of initially pressing, holding, and releasing keys or mouse buttons, let alone handling things like a double click. And how often do you check for user input? If you are constantly checking, then that means the rest of the game is frozen. Fourth, you'll learn how to create and manage all of your game objects and their state. For example, how do you generate a dynamic number of enemies? The factory pattern helps out a lot. Fifth, you'll learn how to apply the game's logic. When do bullet positions get updated? When do more enemies come on screen? How do you know when an enemy is destroyed? When is the game over? I had never used the modulo operator prior to making games, but is littered with all over my game's code. Once you get the basic game working, add a title screen menu, a game over screen, make sure the game runs at the same speed even on different computers, and explore how to implement more interesting enemies with AI. Still not enough? Add shader effects, sound, and online multiplayer. Things to learn are drawing to the screen, handling user input, and game loop. Number 3, a compiler. The most eye-opening projects I've worked on are compilers. Even now, if I have a free Sunday afternoon to do some coding, chances are it is a compiler. It is a great feeling when you create something that enables others to create more things. By implementing one, I had to learn so much about the intricacies of compilers that I normally would never think about. For example, when do expressions get implicitly type converted? I suggest writing the compiler from scratch for a very small, basic-like language, and compile to any other language that you know well. For example, you could write a tiny basic compiler in Python that outputs C# code. It does not have to output assembly or C. Avoiding those will help you focus on the compiler itself. The first hurdle is figuring out how to lex the input code. Then you will parse the code, that is to check the structure of the input and produce a tree representation of the code. The recursive descent parsing technique is beautiful. Next, you will semantically check the input, ensuring the code makes sense and that the type rules are being followed. Finally, you can generate output. This project has a ton of existing resources to help you, and a simple compiler can be completed in a few days. Don't let the jargon scare you. Plus, the possibilities are endless to what you can add. Once you have the basic compiler working, you can add a standard library, optimization passes, and improve the error messaging. Finally, you should write some example programs in your own language to show off to the world. Number 4, a mini operating system. Over the years, I have found myself applying fundamental concepts from operating systems to a variety of domains like games and even predictive models of human behavior. In a classroom setting, the algorithms and data structures used by operating systems might seem abstract or useless, but they really are useful. Implementing an operating system also helped me understand far more about what is going on under the hood. There is a bit of a learning curve and some barriers to get started since it is dependent on hardware. However, by following a book or tutorial, then you should be able to get a bootable OS working that can run your own programs. Last but not least, number 5, a spreadsheet. A spreadsheet application like Excel combines some of the challenges from a text editor with those of a compiler. You'll have to learn how to represent the cell contents in memory and implement an interpreter for the programming language used for equations. That's the end of the video, guys. Thank you very much for sticking around till the end. Be sure to leave a like and subscribe to my channel for more videos like this. If you're interested in learning more about computer science and coding, click the link in my description to my blog where you can expand your knowledge on these topics. See you in the next video!